Hi, this is your Professor Sudha Kolathuparambil, Section 9.4 Hypothesis Test for Proportions. In this section, I am going to explain you the hypothesis test about a proportion using the p-value method and a critical value method. So before explaining the method, let's look at the notations. P is the population proportion of the individual who are in the specified category. X is the number of individuals in the sample who are in the specified category. N is the sample size. P cap is the sample proportion. Let me include one more thing. P naught, that is the population proportion specified by the null hypothesis. The assumptions for performing a hypothesis test for a population proportion is we have a simple random sample. The population is at least 20 times as large as the sample. The individuals in the population are divided into two categories. The values n p naught and n times 1 minus p naught are both at least 10. We can either use the p-value method or critical value method to perform a hypothesis test for a population proportion. So let's look at the p-value method first. So this is the procedure for the p-value method. Step 1, state the null and alternate hypothesis. Choose a significant level alpha, compute the test statistic, compute the p-value. If the p-value is less than or equal to the significant level, reject the null hypothesis and state a conclusion. Let's do an example on hypothesis test for proportion using the p-value method. An educational specialist studying the attitudes of teachers about the use of virtual reality in the classroom. She samples 500 teachers and finds that 471 of them believe that the virtual reality would have a positive effect. Can she conclude that the proportion of teachers who believe it will have a positive effect is greater than 90%? Use significant level alpha equal 0.05. First check the assumptions. We have a simple random sample of teachers. There are two categories, those who believe that the virtual reality would have a positive effect and those who does not. N equal 500 and P naught equal 0.90. So N times P0 is 500 times 0.90, which is 450, which is greater than 10. And N times 1 minus P naught, that is 500 times 1 minus 0.90, which is equal 50, which is also greater than 10. So the assumptions are satisfied. Step 1, state the null hypothesis and the alternate hypothesis. So the null hypothesis is P equal 0.90 and the alternate hypothesis is P greater than 90. Because in the example we are asked whether we can conclude that the population proportion P is greater than 0.90. That's why we took the alternate hypothesis P greater than 0.90. Now choose a significant level. Significant level is 0.05. Step 3, compute the test statistic. The sample proportion P cap is 471 divided by 500, that is 0.942. So use that value 0.942 and P naught is 0.90 and n is 500. That is equal 3.13. Now compute the p-value. So the test statistic is p greater than 0.90. That means that is a right tail. So p-value will be the area to the right of z equal 3.13. So if you are graphing, it is actually area on the right side of 3.13. So from the table, area to the left of z equal 3.13. Left side, this part is 3.13. So here. So that is 0.9991. So area of this part is 1 minus 0.9991 equal 0.0009. So the p-value is equal 0.0009. Now step 5, interpret the p-value. So here p-value is actually less than 0.05. So we reject the null hypothesis at alpha equal 0.5 significant level. Now step 6 is state a conclusion. So we can conclude that more than 90% of teachers believe that the virtual reality would have a positive effect on education. Testing a hypothesis about a proportion using TI-84 plus. First press stat, then test, then 1 prop z test and press enter. Then enter the values of p0, x, n and select from the alternate hypothesis like a not equal p0 or less than p0 or greater than p0 and highlight, calculate and again press enter. We are going to use these values from the previous example and use the calculator to find the p-value. First press stat, test and select option 5, 1 prop z test, and p0 is 0.9, x is 471, n is 500 and null hypothesis that is greater than p0, so select that, then calculate. So use the arrow key and calculate. So p is 8.726 times e power negative 4 means 10 power negative 4. So we can write this without the scientific notation. That means there will be 3 zeros before 8 because 4 decimal places before the decimal. So we are writing without the negative exponent. So this one we can say approximately equal 0.0009. That is the same value we found using the formula and the table. Objective 2 is hypothesis test for proportion using the critical value method. So this is the procedure for the critical value method. First, state the null and alternate hypothesis. Choose the significant level alpha and find the critical values. Compute the test statistic. So this is the formula we are using for that. And determine to reject H0. So for left, right and two tail, these are the conditions, and state a conclusion. So let's look at an example. This is an example of hypothesis test for proportions using the critical value method. A nationwide survey of working adults indicates that only 50% of them are satisfied with their job. The president of a large company believes that there are more than 50% of employees at this company are satisfied with their jobs. To test his belief, he surveys a random sample of 100 employees, and 54 of them report that they are satisfied with their jobs. Can we conclude that more than 50% of the employees at this company are satisfied with their job? Use alpha 0.05 level of significance. So you can see they are surveying 100 employees. So n equal 100 and 54 of them are satisfied. So sample proportion is 54 divided by 100. Okay. And we need to conclude that more than 50% of them are satisfied. More than means when we are defining the null and alternate hypothesis, H1 will be P greater than 0.5. First check for assumption. We have a simple random sample from the population of employees. The sample size is n and P0 is 0.5. So n P0 and n times 1 minus P0 both are 50, which is greater than 10. If the total number of employees in the company is more than 2000, then the population is more than 20 times as large as the sample. So all the assumptions are satisfied. Now state the null and alternate hypothesis. So step 1, state the null hypothesis and alternate hypothesis P greater than 0.5. Step 2, choose the significant level. So significant level is 0.05 and find the critical value. This is the critical region. Area is 0.05. So area on left side of this critical value is 0.95. So use the table and find the critical value. Critical value is 1.645. Or you can find this from the commonly used table. So this is the right tail since it is greater than 5. So right tail significant level 0.05, that is 1.645. So the critical value corresponding to alpha equal 0.05 is Z alpha equal 1.645. Next, compute the test statistic. Test statistic Z equal P cap minus P0 square root of P0 1 minus P0 divided by n. So 0.54 minus 0.5 divided by 100. Now step 4, determine whether to reject at 0. Because it's a right tail test, we reject at 0 if z is greater than or equal 1.645. Because 0.80 is this one, less than 1.645. So since z is less than z alpha, we do not reject at 0. So if you compare the diagram, this is z, this is the critical value 645. This is the critical region area. So 0.8, that is not in the critical region, you can see that. So now we need to conclude that. So step 5, there is not enough evidence to conclude that the company president is correct in his belief that the proportion of employees who are satisfied with their job is greater than 0.5. So the proportion may be equal 0.5. So we can write that. Hypothesis test for proportions, and the notations and assumption you need for the hypothesis test for proportions, and how to perform the hypothesis test using p-value method and critical value method.